take a quick look at the Pythagorean Theorem in 3 dimensions. So we have a rectangular box here, side A, side B, side C. Every corner, every edge at a right angle to every other edge that meets it. We draw a vector from this corner, the lower left front corner, to the upper right back corner. That would be the orange vector. And we're going to say its length is D. How do we get D from A, B, and C? Well, fairly simple. If we draw the vector here from front lower left to back lower right, well, that's got a, you have a right angle here. So you have legs A and B, so this side here would be the square root of A squared plus B squared. So let's see, I don't leave myself room to write that very well, but A squared plus B squared, and there's a square root, and you can't read that, so I'm just going to say square root of A squared plus B squared. That's the length of this vector. Of course, it has components A and B, and we'll worry about that in a minute, but that's not important for what I'm doing right now. Well, that's fine, but now you notice that this line here connects this point, terminal point of this vector, to the terminal point of this vector, and this line is at a right angle to any line in the plane of the base, so we have a right angle here. So now we have a right triangle. Okay, and I'll draw another side of it. This side is C, so D, well, I can write this, D squared equals the square of the length of this leg plus the square of the length of this leg. So that's square root of A squared plus B squared squared, because the length of this leg is square root of A squared plus B squared, plus C squared. So the D squared equals, well, square root of A squared plus B squared is just A squared plus B squared. To that we add C squared. So D is the square root of A squared plus B squared plus C squared. So the Pythagorean theorem in 2 dimensions, where you would have just the A squared plus square root of A squared plus B squared, which we used to find the length of this purple vector, now extends to 3 dimensions. We just add the square of the third leg, if you wish. And this then can be reasonably extended to higher dimensions. We can't draw a rectangular solid in 4 dimensions, but that doesn't mean they don't exist. We just can't imagine them. We can't make one. We can't draw one. So if we had another leg, well, we could add the square of that leg. So it all works. Now, we're going to see what this has to do with the dot product.